today's mindful moment. We like to think that numbers don't lie, right? They just give us this hard truth. But what if I told you that even those solid statistics you see could be massaged?
Twisted even.
Yeah, twisted, even strategically cherry-picked to paint a totally misleading picture.
It's true. And that's what we're going to be diving into today.
It is, and it's a fascinating topic and frankly really important, I think, for everyone to know a little bit more about because, we get bombarded by statistics all the time.
All the time, every day. Yeah.
So we're going on a deep dive today all about uncovering how statistics can lie.
Because they can, and it's not always malicious.
Right.
Sometimes it's just somebody's trying to make a point or spin things in a certain direction or whatever. But the point is that statistics are representations of something else.
Right.
And so that representation can be, massaged or manipulated to mean different things.
Yeah, absolutely. And our guide through this kind of potentially deceptive statistical landscape is the seminal work, How to Lie with Statistics.
It's a classic.
It is a classic by Darrell Huff and Irving Geis.
Yeah.
And we're going to be extracting these core insights to equip you, the listener, with the skills you need to spot this statistical sleight of hand when you see it in your everyday life.
Exactly.
So our mission is to empower you to question the numbers you see and become a truly informed skeptic.
Yes.
So let's jump right in to our first deceptive statistical technique.
Let's do it.
The sample with the built-in bias.
Oh, this is a good one.
This is a good one. Imagine you want to learn something about, let's say, I don't know, like how people feel about a particular issue or product or whatever. And so you conduct a survey.
Right.
But you only survey people in a very specific location or demographic.
Okay.
The results you get from that survey are only going to reflect the views of that particular group.
Got it.
And may not be generalizable to the wider population that you're actually interested in.
Yeah.
That's a sample with a built-in bias.
Yeah.
So it's like if you were trying to find out how people felt about a certain political candidate and you only surveyed people at a rally for that candidate.
Exactly.
You're going to get a very skewed result.
Yeah, absolutely. You're only getting the opinions of people who are already inclined to support that candidate.
Right.
You're not getting a representative sample of the general population.
Right. And the book gives a really good example of this.
Yes, they do.
With the reported average income of Yale graduates from the class of 1924.
Oh, yeah. This is a great example.
Which was a whopping $25,111 a year.
Now, back then, that was a lot of money.
A lot of money.
Big money.
Huge. And this was reported by Time Magazine. So you figure like, okay, Time Magazine, they're pretty credible.
Right. You would think.
You would think. Where did they get this number from? Like, how did they come up with this?
Well, this is where it gets interesting.
Right.
The authors suggest that Time probably surveyed the alumni.
Okay. Makes sense.
Makes sense, right? But think about it. Who is most likely to respond to a survey like that?
The people that are doing well, probably.
The ones who are successful, the ones whose addresses are easy to find, the ones who are proud to share their income.
Yeah, exactly.
What about the graduates who maybe haven't achieved that level of financial success?
Right.
The ones the authors call the little lost sheep.
Right.
Are their addresses as readily available? Are they as eager to disclose their earnings?
Probably not.
Probably not. And so the method of data collection itself introduced a bias right from the start.
Right.
The sample wasn't a random slice of the entire graduating class. It leaned heavily towards the more successful and likely more affluent graduates.
So even if it wasn't intentional,
right,
this flaw in how the sample was chosen leads to a result that doesn't really represent the whole picture.
Exactly.
So for you, the listener, think about this. Have you ever seen a survey or a study where the results just felt kind of off?
It happens all the time.
Maybe it was overwhelmingly positive reviews for a product that you're like, I don't know about that.
Or a poll with surprisingly one-sided results.
Right.
In those instances, always think about the source and how those participants might have been chosen.
Right.
Was it an opt-in online poll?
Right.
Or was it a carefully controlled random sample?
Right.
The way the sample is put together is a major factor in how you should look at the information they're giving you.
Totally. So let's move on to another common statistical tactic.
Okay.
The well-chosen average.
Oh, yeah.
And, we hear the word average all the time.
All the time.
But it turns out there's more to it than meets the eye.
There's actually 3 different types of average.
Okay. I'm listening.
There's the mean, which is what we typically think of as the average.
Okay.
You add up all the values and divide by the number of values.
Right.
Then there's the median, which is the middle value when you arrange all the values in order.
Okay.
And then there's the mode, which is the value that appears most often. And each of these can tell a different story.
Okay.
And so someone who's trying to, present a particular viewpoint might just pick the average that makes their argument look the best,
Right.
even if it's not really the most accurate representation of the data.
So, for example, if a company boasts an average wage of, let's say, $5,700,
Right.
It creates an impression that, like, everybody's doing pretty well there.
Yeah, you think so, right?
Right. But what if the median wage is only $3,000?
Yeah, that's a big difference.
That means half of the employees are making less than $3,000.
Right, exactly. And the most common wage might be even lower, say $2,000.
Right.
So you got a few people making a lot of money pulling that average up,
Right.
but the majority of the workers are actually making significantly less.
And that can happen, like you said, in a company where you have a couple of founders who are doing very well.
Oh, absolutely.
Right.
Especially these days with, startups and tech companies and stuff like that. You've got, a handful of people at the top making a ton of money,
Wow.
and then everybody else is, making a much more modest salary.
Right.
So if they only report that mean salary,
Right.
it makes it seem like everyone's getting paid a lot more than they actually are.
Got it.
But the median and the mode would give you a much more realistic picture
Yeah.
of what the typical employee is actually making.
So the key thing here is when you hear the word average, you have to ask.
Which average is it?
Yeah, which one are we talking about?
Exactly, because a single average figure without any context can be very misleading.
Totally.
Yeah.
So let's move on to our next little statistical trick.
All right.
The little figures that are not there.
Ah, yes.
What is that all about?
This one is all about using small sample sizes to make big claims.
Okay.
So you see a headline that says something like, this new miracle drug cures 90% of patients.
Wow.
Sounds impressive, right?
It does.
But what if that study was only conducted on like 10 people? 9 out of 10 is 90%, but that's not really a lot of data to go on.
Right.
The sample size is just too small to draw any meaningful conclusions.
Right. Like flipping a coin 5 times and getting heads 4 times doesn't mean that the coin is going to land on heads 80% of the time.
Exactly. It's just not enough data to be statistically significant.
So you really have to consider the absolute numbers behind those percentages.
Absolutely, because without knowing the total number or the sample size, those percentages can be very misleading.
Right. So for the listener, anytime you see a big percentage or a really specific number,
Yeah.
but they don't tell you how many people were involved,
Be skeptical.
be very skeptical, because it could be that they're just using a very small sample size
Yeah.
to make their claim seem more impressive than it really is.
Exactly.
So our next deceptive technique is much ado about practically nothing.
Oh, yeah. This one's a good one, too.
Tell me about it.
So this is when you make a big deal out of differences that are statistically significant,
Okay.
but so small that they don't actually matter in the real world.
Okay, I see.
Like, let's say you have 2 groups of students.
Okay.
And one group scores slightly higher on a standardized test.
Okay.
Statistically, you can say that there's a difference between the 2 groups.
Okay.
But if that difference is only like a fraction of a point,
Right.
it doesn't really mean anything in terms of their actual abilities or their future success.
Right. It's kind of like saying that one brand of coffee has 0.001% more caffeine than another brand.
Yeah, exactly.
Like, you're never going to notice that difference.
You're never going to feel it.
Right.
But they can still say, oh, ours has statistically more caffeine.
Statistically more, but practically meaningless.
Exactly.
So the important thing here is to consider the context.
Absolutely.
Does the comparison they're making really tell you anything meaningful about the difference between the two things?
Right. Is the difference big enough to actually matter in the real world?
Yeah. And a lot of times the focus is just on that statistical finding itself.
Yeah, just the fact that there's a difference. They're not really thinking about whether it's a meaningful difference.
Okay, so let's get a little visual now
Right.
with our next deceptive tactic, the gee whiz graph.
Ah, graphs. You can do so much with a graph
Okay.
to make your point.
Oh, yeah. Tell me about it.
So graphs are really good at showing data visually.
Right.
But the way you design that graph can have a huge impact on how people interpret that data.
Yeah.
And one common way to manipulate a graph is to mess with the scales on the axis.
Okay.
So imagine a graph showing a company's profits over 5 years.
Oh, okay.
If you start the vertical axis, let's say at like $50,000,
Right.
instead of 0,
Right.
even a small increase in profits is going to look like this huge spike
Right.
because you've zoomed in on just the top part of the graph.
Right. You've truncated the axis to make it look more dramatic.
Right.
And the book has a really good example of this with 2 graphs that show the same data on government payrolls.
Yeah.
One graph is titled GOVT, payrolls up P,
with an exclamation point.
with an exclamation point. And it uses a really compressed vertical scale
Right.
to make a pretty small increase look huge.
Yeah, it's like rocketing up.
Right, exactly. And then the other graph is titled GOVT, payrolls stable.
Much more boring.
Right.
Yeah.
But it shows the exact same data. But this time, the vertical axis starts at 0.
Right.
And suddenly that dramatic increase looks like a flat line,
Really flat.
which is actually a more accurate representation of the data.
Exactly.
So the numbers haven't changed. It's just the way they're presented visually.
That's it.
That's creating a different impression.
Yeah, and this is something you see all the time.
All the time.
In advertising, in the news, everywhere.
Everywhere.
People are always tweaking the scales to make their point look better.
So the takeaway here for the listener.
Look at the axes.
Look at the axes.
Always look at the axes.
Where do they begin?
What are the increments? Are the scales consistent?
Right.
These little details can totally change how you see the data.
Absolutely. And speaking of visual deception, let's move on to the one-dimensional picture.
Oh, yeah, another classic.
What is that?
This is when you use images to represent numbers,
Okay.
but you only scale one dimension of the image,
Okay.
which makes the comparison look distorted.
Okay.
So our brains tend to interpret the size of an image as a whole,
Right.
right? We look at the area, the volume.
Yeah.
But if you only change one dimension, like the height,
Right.
the visual impact is going to be way bigger than the actual numerical difference.
Okay.
So let's say you're comparing military spending between two countries,
Okay.
and you use pictures of soldiers to represent that spending.
Okay.
If one country spends twice as much as the other,
Right.
you might draw their soldier twice as tall,
Okay.
but visually, that taller soldier looks way more than twice as big.
Right.
Because we're seeing the difference in volume, not just height.
Right.
So it exaggerates the difference in spending.
So it's like if you're comparing the size of two economies
Yeah.
and you use pictures of coins and you make one coin twice as tall as the other,
Exactly.
that bigger coin is going to look way more than twice as big.
Way bigger. And it
Yeah.
gives a false impression of the actual difference in size between those economies.
Right. So anytime you see quantities represented visually,
Pay attention to the scaling.
right, make sure that all the dimensions are scaled proportionally.
Otherwise, you could be getting tricked.
Exactly. So our next technique is the symmetric figure.
Ah, yes. The sneaky statistic.
Tell me about it.
This is where you use a statistic that's technically true,
Okay.
but it's completely irrelevant to the point you're trying to make.
Okay.
So you create this kind of false connection in the viewer's mind.
Okay.
Like a classic example is those old cigarette ads that used to say things like, 9 out of 10 doctors smoke this brand. Oh, yeah, I remember those.
Right. They're trying to make you think that doctors are endorsing this brand.
Right, like it must be healthy if doctors are smoking it.
Right. But they don't actually tell you why those doctors smoke that brand.
Exactly.
Yeah.
Maybe it was the cheapest brand.
Right.
Maybe they got free samples.
Right.
The statistic itself doesn't say anything about whether that brand is actually better or healthier.
Right. And the book gives another good example talking about how there are more traffic fatalities on sunny days than on rainy days.
Oh, yeah.
So someone might try to argue that sunny weather is more dangerous for driving.
Right. Clear skies equal danger.
Right. But they're leaving out a crucial piece of information,
Which is
which is that people drive a lot more on sunny days.
way more.
So of course there are going to be more accidents.
Yeah, it doesn't mean that sunny weather is inherently more dangerous.
Right. It just means there are more opportunities for accidents to happen.
Exactly.
So whenever you see a statistic like that,
Ask yourself, what's the connection?
yeah, what's the actual relationship between that statistic and the claim they're making?
Is there a logical connection?
Right. Or are they just trying to trick you?
Exactly.
Okay, so up next we have post hoc rides again.
Ah, yes. Correlation versus causation.
One of my favorites.
Everyone's favorite.
So what is that all about?
Well, this is the classic fallacy of assuming that because two things happen together,
Right.
one must have caused the other.
Right.
But that's not always the case.
Right.
Just because two things are correlated doesn't mean they're causally related.
Yeah.
There could be other factors involved, or it could just be a coincidence.
Like the classic example is that ice cream sales and crime rates both go up in the summer.
Right.
So does that mean that eating ice cream causes crime?
Not necessarily.
Right.
It's more likely that there's a third factor at play.
Right.
Like hot weather.
Right.
Hot weather makes people want ice cream, and it also makes people more likely to be outside,
Right.
which could lead to more opportunities for crime.
So the correlation doesn't equal causation.
Exactly.
And the authors have this funny little anecdote in the book about a guy who starts wearing a new hat.
Okay.
and then he gets a headache.
Uh-oh.
And he blames the headache on the hat
Oh, no.
because he started wearing the hat right before he got the headache.
Just because it happened after doesn't mean it was caused by.
Right, exactly. And it just shows how easy it is to jump to that conclusion.
Yeah, we're always looking for patterns,
Right.
trying to make sense of the world.
Right.
And sometimes we see connections that aren't really there.
So whenever you see a claim about cause and effect,
Think about other explanations.
right,
Could there be another reason why these two things are happening together?
don't just assume that because B happened after A, that A caused B.
Right, exactly.
Okay, we're nearing the end of our deep dive into statistical deception.
Almost there.
And now we come to how to statistulate.
This is my favorite.
This is a great one. What is statistulating?
Statistulating is the art of using language and presentation
Okay.
to manipulate how people interpret statistics. So
Yeah.
you can take the same data
Right.
and present it in very different ways,
Okay.
depending on what you want people to believe.
Okay.
Like a company might announce that their profits have increased,
Yeah.
but they don't mention that their overall revenue has actually gone down.
Right. So it makes that profit increase seem more impressive than it really is.
Exactly. Or a news report might focus on a decrease in the unemployment rate,
Okay.
but they don't mention that fewer people are actually looking for work.
Right.
So the unemployment rate is going down.
Right.
But it's not necessarily because more people are finding jobs.
Right.
It's because people are giving up on the job search.
So they're not even counted as unemployed anymore,
Exactly.
even though they're still not working.
Right.
So statistulating is really about choosing your words carefully.
It's about framing the data in a way that supports your agenda,
Right.
even if it's not the whole story.
So how do we fight back against this?
Well, the book gives us a handy set of questions to ask whenever we encounter a statistical claim.
Okay, give them to me.
Question number 1, who says so?
Okay.
Consider the source and their potential biases.
Right.
Number 2, how do they know?
Okay.
Look at the methodology and the sample size. Number 3, what's missing?
Okay.
Is there any data that they're not showing you? Are there alternative interpretations of the data?
Okay.
And number 4, did somebody change the subject?
Okay.
Are they making comparisons that are irrelevant or misleading?
Right.
So those 4 simple questions can really help you think critically about the statistics you encounter.
Yeah, and for the listener, you might find even more insights into this kind of critical thinking on a YouTube channel called Mindful Moments,
I've heard of that one.
which does AI audiobook analysis and kind of looks into these ways of thinking.
That's cool.
Yeah. So what is the key takeaway here?
Statistics are powerful tools,
Yes, they are.
but they can be very easily manipulated.
Yes.
Critical thinking is essential in a world that's just overflowing with data.
So now that you've seen how numbers can bend, what other information in your life that seems objective deserves a closer look?
That's a great question. Are there other areas where maybe you're accepting things at face value without really questioning them? It's worth thinking about?
It is, and I think that's a great place to leave it for today.
I think so too.
So for more insights into the information that shapes your world, make sure you subscribe to Mindful Moments.
And share this episode with anyone who could benefit from a little statistical literacy boost.
Yes, and to really dive deep into this topic yourself, you can purchase a copy of How to Lie with Statistics using the link in our show notes.
It's a great book.
It's a classic, and most importantly, keep thinking critically
Always.
out there.